2, 3. We are going to skip 2, 2. So you're probably wondering, like, where'd 2, 2 go? It's gone. We didn't do it. And we're going to go ahead and go to 2, 3, which is going to be our discussion on higher degree polynomials. Higher degree polynomials. So you probably feel pretty comfortable with lines and parabolas. Do you? Yes? That's a yes. Pretty good, okay? Now we're going to get into cubics and quartics and all kinds of things. So what we're going to do is we're going to graph these graphs by hand. We're going to find the zeros. We're going to do all kinds of stuff. So the first thing you need to know is something called the leading term test. The leading term test. Now polynomials, as you know, can get pretty lengthy. If you have a bunch of terms, you know, like all of them, but none of them really matter except for that first one when it's in standard form. That's the one that matters the most. Okay, so here we go. First of all, you do know the degree of a polynomial, right? Degree of a polynomial is its leading exponent when it's in standard form. Leading exponent in standard form. Standard form of a polynomial is descending order of exponents. And so, for example, if you had p of x equals negative 5x to the fourth plus 3x squared minus 10x plus 1, for example, okay? Just made that up. That would be a polynomial. It has 4 terms, and it has degree what? Degree is 4. It's a 4th degree polynomial. Okay, it's a quartic. You don't have to know those words, but you do need to know it's 4th degree. So what we're going to do, I'm going to teach you this leading coefficient or leading term test. It used to be called leading coefficient test. Now it's called leading term test. And the leading term test is we're going to look at this and ignore the rest of it. Okay? And what we're looking for is we're looking for whether the leading coefficient is positive or negative, because that's going to affect our graph, right? Think about a negative parabola. What does that do? Makes it point down, yeah. And then we're also going to look at whether that is even or odd. Okay? So here we go. Here's the leading term test. So let's say that the degree of the polynomial is n, where n is, you know, a number. And if n is odd, we're going to make a chart here. If n is even, and then we also need to do if the leading coefficient is positive or if the leading coefficient is negative. I have so much better writing than this. This iPad's really not good for me. All right, so here we go. This is what it looks like. So let's start. If we're going to have 4 graphs here. Okay, so we're going to have an odd positive, an even positive, an odd negative, and an even negative. And this is going to determine the left and right hand behavior of the graph. Like, what's it doing all the way to the left when x goes to infinity? What's it doing all the way to the right? Well, x goes negative infinity and positive infinity. So here we go. Let's start with the first one. If your degree is odd, but your leading coefficient is positive, that means that your graph is going to fall to the left and rise to the right. Think about just your regular basic cubic function. Now, then this graph could come through here, who knows how many times, it doesn't matter, okay? But if it's odd and positive, it will always fall to the left and rise to the right. Right? Picture y equals x cubed. Y equals positive x cubed. Falls to the left, rises to the right. Now, if it's even, if it's an even function with a positive leading coefficient, think about a parabola, a positive parabola. They will rise to the left and rise to the right. And then it might come through here a few times. Who knows? Depending on how big the even is. If it's 6, 8, it could have 10 zeros. Zeros would pass through the x-axis. Okay, and now everything gets flipped. So if you have a odd leading coefficient of negative, then it's going to flip this way. It's going to rise to the left and fall to the right. And it's going to go through here a few times, maybe. And then finally, an even negative. Think about a parabola that's negative out front. That would be fall, fall. Okay? You need to know that. You need to know this chart. But just remember, just think very simple terms. Think about your x squared and think about your x cubed and what it does. You know these from the last chapter. All right, so let's do one. Here we go. Number 1, it's going to ask you to describe the end behavior. Okay, the end behavior. Now let me show you how the book is going to write this sometimes. The end behavior, it looks like this. The limit, okay, we're not really doing limits yet, but they introduce limits here. The limit as x goes to infinity for your polynomial, for your function, okay? What that means is as you're going out towards infinity on your graph, what is your y value doing? What's the y doing, okay? And so that would be the end behavior. This would be the end behavior to the right. So they might list it like that. I'm not really going to do limits with you until the end of the school year, when we get to the last chapter, but they like to introduce it here for some reason. Now, if they do say the limit as x goes to negative infinity for your function, then that means we're looking at the end behavior to the left. Okay? To the left. All right, so that's so you know the notation and what it looks like. Don't worry too much about that. So let's do one. Here we go. Let's say our polynomial f of x is equal to 5x to the 6th plus 3x to the 5th minus 10x minus 4. Okay? All right. We're going to talk about the end behavior. End behavior is all the stuff that's happening to the left and all the stuff that's happening to the right. The end of the graph. There's really no end of the graph. So what you're going to do is you're going to basically ignore all of that. Okay? When it's written in standard form, you are looking at just this. That's having the biggest effect on this polynomial. And what you want to do is you want to look to see whether it's positive and whether the exponent is even or odd. Okay? So this is a positive, even function. Positive, even. Not even function, but an even degree. Sorry, it's not an even function. Positive, even degree. And what happens for positive even is it's going to rise to the left and rise to the right. Okay? Rise to the left and rise to the right. And that's all they want. You just describe it. Now, if they want you to write it in the fancy stuff, you would say the limit as x goes to infinity for this function. As x goes out to infinity, your graph goes to infinity, positive infinity. Okay? As your limit as x goes to negative infinity for f of x, it still goes to positive infinity. Okay? So like you think about it like a graph like this, it's rising here, rising there. Who knows what's happening in the middle? But as you go that way, your graph is going up to infinity, and as you go that way, your graph is going up to infinity. So that's what this fancy stuff means right here. Now, what do I expect of you? I expect you to say rise left and rise right. Okay? We'll keep it nice and easy. Bobby didn't like that. All right, here we go. Letter B. Let's try one more. Ooh, I'm going to try and trick you, because that's what math teachers are out to do. We're out to trick you. Yep. Yep. We get together in our meeting. We're like, how are we going to get them this year? Yeah, we really do. All right, f of x equals negative x to the 4th plus 5x cubed minus 7x to the 9th. Tricky. All right, I didn't write this in standard form because, I don't have to. Yeah. So what you're going to do is you're going to look at what should be the leading coefficient and the leading term, okay? And in this case, it should be this one right here, right? And we should ignore the rest. So you're looking at negative 7x to the 9th. Negative 7x to the 9th. So this one has a negative leading coefficient, and it has an odd degree. And so you can go to your chart, or you can just think about y equals, in my mind, this is what I think, y equals negative x cubed. That is a negative with an odd degree, okay? They're all going to look the same at the end. They do. You know how a negative x cubed looks, right? It looks like this. Yeah? Well, this negative 7x to the 9th, guess what that's going to do? It's going to do the same thing, but maybe do something weird in there, okay? But the outsides are what we're really looking at. So what I would expect from you to write for this answer would be rise to the left and fall to the right. All right? You got it pretty good? Yeah, we're ready to move on? Okay. All right, part B. Part B. So that is going to tell us what the outsides are doing. Now, the question is, what's going on here? What's going on in the inside, right? We need to know that too. All right, so part B. We're trying to graph these polynomials by hand. So we know what the outside does. Let's find out what the inside does. The inside we're going to focus on is our zeros, okay? Zeros, if you remember, are the x-intercepts of the graph. And the way that you find these is you are going to factor. You're good at factoring. You know how to factor. You know how to factor everything, right? We're going to factor our huge polynomial into its factor so that we can find its zeros. The zeros are the x-intercepts. They're also called roots, and they're also called solutions. They're solutions when p of x is equal to 0. Okay? So those are all interchangeable. X-intercepts, zeros, roots, solutions, all of those words are the same. Now, here's what you need to know. Let's say that we still have our degree of our polynomial is equal to n. Okay, that's going to be important because your polynomial will have at most n zeros. Okay, so if it's a quadratic, you will have at most 2 zeros. Now, why do I put in the word at most? Well, because if we had something like y equals, let me just do an easy one real quick, x squared minus 6x plus 9, okay? And if I were to factor this to find the zeros, I would have x minus 3 and x minus 3. So what happened is I get x equals 3. I get 1 0, but it happened how many times? It happened twice. So I really have 2 zeros, okay? You could go 3 and 3. Okay, I'm going to teach you a word. Actually, you learned it last year, I think. Okay, so at most n zeros. At most n zeros. And then when something happens like this, where you have multiple ones, it's called, do you remember? Multiplicity. You learned that last year in Algebra 2. Multiplicity. There used to be, well, there was a movie out long time ago with that Batman guy. What's his name? Keaton? Michael Keaton. And it was called Multiplicity. And he, like, cloned himself. There was a whole bunch of them. It's a really dumb movie. Okay. Anyway, so the multiplicity is... No, I know. Yeah, you'd rather do that than this, huh? The number of times a 0 repeats. The number of times a 0 repeats. Now, you can't say something has a multiplicity of 1. That doesn't make sense, okay? So a multiplicity is 2 or more. All right, so let me show you an example of that really quickly. Here's an example. Let's say you have f of x equals x plus 1 squared, x minus 3 cubed, and x plus 4. So here's a polynomial. It's already factored for you. And we are going to find the zeros and state their multiplicities if they have any, okay? So you want to get it in factored form. This one's already factored. I remember putting something like this on a test or quiz, and I had someone FOIL the whole thing out and just waste all their time. You don't want to do that. Yeah, we don't want to FOIL that out. Yeah, it was terrible. Like, I didn't even get to question number 3. I'm like, well, that's because you were FOILing the whole time. All right, so anyways, x equals -1 is a 0. If I plug in -1 into this polynomial, the whole thing is 0. And that has a multiplicity of 2. Perfect. Okay, if I say the next one is x equals 3 is a 0, and it has a multiplicity of 3. It happened 3 times. See that x minus 3? It's x minus 3 times x minus 3 times x minus 3. It happened 3 times. And then my next 0 would be negative 4, and it does not have a multiplicity. Okay? Do you know what the degree of this polynomial is? Nope. 6. 6. These are all being multiplied together. If I were to spend my time foiling this out, which I would never do, you're going to get 3 and a 2 and a 1 here. There's 3, 4, 5, 6. Degree is 6 here. Okay? And there's 6 zeros. They're multiplicities, but there are 6 of them. Now, how are we going to graph this? This is going to be crazy. I wanted to show you on your calculator what this looks like. So I'm going to plug it in real quick. X plus 1 squared. We're not really using our calculator, so you don't need to get it out. But I just wanted to show you what this is going to look like. X plus 4. Zoom 6. Okay. So here it is. Weird stuff. All right. So let me go ahead and tell you what's happening here, okay? So these are zeros, negative 1, 3, and negative 4. And so those are going to be our x-intercepts. So you want to go ahead and plot those, okay? So do this with me. So go to negative 1, and we're going to plot that right there. And then negative 4. And then positive 3. Okay, so those are good. You got your zeros. You know what's happening there. With the degree being 6, that's important, okay? It's 6, and the leading coefficient, see how all the x's are positive? The leading coefficient is going to be positive 2. So it's an even degree with a positive. That means it's going to rise to the left and rise to the right. Now take a look at this graph that I showed you. There's some interesting things here. At negative 4, it looks like a vertical line. It's not, okay? At positive or negative 1, it looks like a parabola there. And then over here, it kind of does this weird like thing. Now this is what happens at each different factor. At x plus 1 squared, at negative 1, it's going to act like a parabola. Yeah. At negative 4, which was a degree of 1, a multiplicity of 1, which really isn't a multiplicity, it acted like a line, which is degree 1. Over here, this one had a multiplicity of 3. It acts like a cubic function there. So this is how you would graph this. You would just come through negative 4, like normal. You'd go to negative 1 and act like a parabola. Okay? Don't go up through here anywhere else but these points. So it come through like a line here, through like a parabola here, and then over here it would act like a cubic function. Okay? This right here has a multiplicity or degree of 1. This one right here had a multiplicity of 2, and this had a multiplicity of 3. So they're going to act like each of those things. It acts like a line here, it acted like a parabola there, and it acted like a cubic function there. Isn't that so cool? Yeah. No, you loved it. Okay, let's do some now. Are you ready? We've got 1, 2, 3 examples, and then we're done. Ooh, you're going to have time to work. All right, so, oh, and hi, period 1. Hope you guys are having a great day. I'm flying to Seattle right now.
I just realized that you're like constantly zooming in.
Uh-huh.
So as you zoom out, it's just like a staircase.
Yes, you see? That's all we've learned today. That's it. It's very, very small amount, yeah, if you look at it. Like, that's how God sees us, right? Like a tiny, but he knows all of us. Okay, see the connection there? All right, number 2. Here we go. We are going to do a couple of things. We are going to determine the zeros, the end behavior, and we're going to sketch a graph. Now, I'm not too concerned. Did you notice on this last problem, like how come I didn't go down so low and what happened there? I'm not concerned about that, okay? That's not really that important. We can do that on our calculator. But this is, I want the zeros and I want to know which way it's going. Okay? Ooh, I feel like I'm doing Zumba. Anyways, I'm terrible at it. Letter A, here we go. Let's do it. We have f of x equals, we'll start with an easy one, okay? 2x squared minus 18. Simple quadratic. Now we are going to find the zeros, the end behavior, sketch the graph, all without our calculator. So the first thing you want to do with these problems is you want to factor, okay? So let's go ahead and we're going to factor this. So it has a GCF. Make sure you look for the GCF. And we're going to factor out a 2 first to get x squared minus 9. And then we're going to factor some more. You factor until you can't factor anymore. And so you get 2 times x plus 3 and x minus 3. And now we're going to sketch this. So here we go. You don't have to have a grid. If on the next quiz, I will just have this. I won't have any tick marks at all. It's just going to be 2 lines like that. And so what you want to do is you want to find the end behavior, so left and right, what it's doing. So it's a positive even, which means it's going to be up, up. It's a positive parabola. Okay, you know that. And then the zeros are x equals plus or minus 3. So you go over here to 1, 2, 3, put a dot. 1, 2, 3, put a dot. And then you just draw your parabola. Now, how low does it go? We don't really care. I know it might bother some of you, but we want just a sketch of the graph. So what I'm looking for is that your parabola or graph is opening the correct way and that you have the zeros graphed. Okay? Pretty good, right? Isn't that nice? Yeah, it's not too bad. We're putting all the stuff together. All right, here we go. Next one. 2 more. Let's say g of x now is equal to x to the third minus 3x squared minus 9x plus 27. They're all going to be factorable right now. I mean, sometimes, a lot of times polynomials aren't factorable, but they're going to be factorable. And do you remember how to factor this when you have 4 terms? Yeah, grouping. You got to split it up. Exactly. So we're going to take this and we're going to split it down the middle, and we're going to factor by grouping. It's one that you forget, but when you see 4 terms like that, try to remember that, okay? So let's go ahead and factor out an x squared out of the first 2 terms only. You get x minus 3. And then over here, factor out a negative 9, and you're left with x minus 3. Now, with grouping, that will always be the same. This and that will always be equal, okay? So now let's get them together. We're going to factor an x minus 3 out to the front, and you're left with x squared minus 9. Get rid of that. X squared minus 9. We just factored that a minute ago, so that can be factored again. So you get x minus 3 here, and then this factors as the difference of 2 perfect squares, so x plus 3 and x minus 3. Now, here's some good advice. Get your same factors together, okay? So I have g of x equals x minus 3 twice squared and x plus 3. Okay, so we're ready. We have completely factored it. We're ready to find the zeros. So the zeros are going to be 3 with a multiplicity of 2. It's very important that you write that, okay? Because it's going to affect the graph at 3. At 3, it's going to look like a parabola because it has a squared on it. And then negative 3, and that one's just a single. Okay, so those are our zeros. Our end behavior, this is an odd degree with a positive leading coefficient. It's an odd positive. Okay, so we're ready to graph. Here we go. Odd positive means I'm going to go fall to the left and rise to the right. Just a little reminder of that. And then our zeros are at 3 and negative 3. It's just like the last graph. That quadratic we did had the same zeros, 3 and negative 3. But this one's a cubic function, so it's very different than the other one. So at 3, right here, I'm going to just touch that and come back down, okay? Or go back up, actually. So here, let me show you. You're going to go through negative 3. You're not going to go through this like a line, Because this has a degree of 2, you're going to treat it like a parabola and go back up. Do you see that? Now, here's the biggest mistake people will make on this. I'm going to write it in red because it's bad. They'll go over here to -3. They'll go over here to +3. They know this and they know that, right? So they'll go like this. Oh, okay. You know what you just did? You just created another 0 in the polynomial. There's no 0 there. We found the zeros, right? People do that all the time. They want it to work, right? You're trying to make it work. The only way this works is it's going to go through here. It's going to bounce off because it's a multiplicity of 2, and then it goes up like that. Okay, so just remember that. It's very important. All right, last one. Let us see. Okay, let's do this one. H of x. We'll call it h of x. H of x equals -2x to the 4th plus 2x squared. Okay. All right, so this is a negative even. So I know that it's going to fall left and fall right. It's going to be down, down. So let's go ahead and factor it. Let's factor out a -2x squared from both terms. If I factor out a -2x squared, I'm left with x squared minus 1. Can I keep going? Yep. Difference of 2 perfect squares. People forget that 1 is a perfect square, but it is. So x plus 1 and x minus 1. All right. So let's talk about this. So at most, it's going to have 4 zeros. Okay. I like to think that it has 4. I like to count the multiplicities as twice or 3 or whatever. So our zeros are going to be from here. I get 0 with a multiplicity of 2. It happens twice. It's squared. It's x times x. There's 2 zeros there, and they just so happen to be both 0. And then I have -1 and +1. So those are my zeros. I know that it's going to fall down left and fall down right. And so I'm ready to graph. Okay? All right, so down, down. Even, negative. Even degree, negative leading coefficient. And now let's plot our zeros. We have -1, 0, and +1. Okay? So here we go. -1 and +1 are linear. They have one single 0 for each of them. So through that, you're going to just make it look kind of like a line. It's just going to be straight, you know, it's not really straight up, but it's pretty close. At 0, we have a multiplicity of 2. That's where I get that parabola shape right there. It bounces off, and then it's going to come back down through +1. So that's what the sketch of the graph would look like. Pretty ugly, huh? Yeah, it's a good one.